Welcome to a tutorial of Proflan YouTube channel. In this particular video, we're going to have a continuation of this paper of October-November 2024. So we're going to look at question number 8, whereby the diagram shows two whales in a sea. The species of whale communicate with sound signal and visual signals. Describe the difference between the motion of particles in transverse wave and longitudinal waves. And in this kind of question, you may draw a diagram to help your answer. So in this case, we need to realize that longitudinal waves, particles vibrate parallel to the direction of the wave, but in transverse waves, particles vibrate up and down, perpendicular to the direction of the wave. So you are supposed to say that in transverse waves, particles vibrate perpendicular to the direction of the wave, while in longitudinal waves, particles vibrate parallel to the direction or to the wave direction. And if you are new to Proflan YouTube channel, consider subscribing so that anytime we are going to upload a tutorial, you'll be notified. So when whale A swims towards whale B, the frequency of sound detected by whale B increases, and this is known as Doppler effect. We are supposed to explain how Doppler effect causes frequency of a sound wave to be detected by whale B to increase. Now you see, if an object is moving this direction, the wavefronts will be very close, and if the wavefronts are close, it means the wavelength is short. Therefore, since speed is constant, frequency has to increase, because if the wavelength has decreased and the speed remains constant, then frequency has to increase. So that's why I say that wavefront at whale B are compressed, and since speed of the wave is constant, then we can use the formula V equals to F lambda, then the frequency must increase. Now you see, if it's due to Doppler effect, if this dolphin makes noise, a lot of sound, and it's moving in this direction, the wavefronts here will be compressed, they will be very close. So this is high frequency. So whale B will hear sound of high frequency. This also happens when an ambulance is passing through two observers. If the observer is behind the ambulance, will hear sound of low frequency because the wavefronts are quite spaced, but this person here will hear sound of high frequency. Now, if you are asked to define Doppler effect, we are going to say Doppler effect is the phenomenon that occur due to relative motion between the source and the observer. So the frequency is going to be changing when we are talking about Doppler effect. So a person who is in front of the source and the source is approaching will hear high pitched sound than the person who's behind, who will hear a low pitched sound, because we know frequency determines the pitch of sound, but amplitude determines how loud a sound is. Now, visible light from the sun reaches whale B, and the wavelength of light is 5.4 times 10 raised to the power -7 meters. We are supposed to calculate the frequency of this light, and we are going to use the wave equation, and then we substitute so that our answer becomes 5.6 times 10 raised to the power 14 hertz. We are going to change the gear and move to electricity, and these are the equipment that are provided, whereby the student investigates different electrical components, and the student first investigates how voltage of a diode affects the current in the diode, and then we are going to use this equipment. So to draw the circuit, we are supposed to have an ammeter, which is here. We have a variable resistor to vary the amount of current in the circuit. We shall have the cell here, and then we have a voltmeter which is connected parallel to this device here. Something else that you need to understand is that when current flows in a junction where we have parallel components, current is going to split, and more current will flow where there is less resistance. So meaning this component A could be having less high resistance than B, because that less current is going this direction. Yeah, so B has low resistance, so more current will be passing here. So what you need to realize is that when components are connected in parallel, they will be having the same voltage. They should have the same voltage but different amount of current, but same voltage. Calculate the current in the battery, and of course, in order to calculate the current in the battery, we are supposed to add these two, because these two currents are splitting from this point, so it will be 0.15 amperes plus 0.23, and that's going to give us 0.38. The next question is for us to write the equation connecting voltage, current, and resistance. This is Ohm's law, and that is the equation V equals to IR. To calculate resistance in A, we need to remember that the voltage in A is the same as 2.9. The voltage in B will be the same 2.9 because these components are connected parallel. Then use the formula. The formula to use for resistance is V over I. So the current for A is basically what is 0.15 divided by the, so it will be 2.9 divided by 0.15, and the resistance in that case is going to translate to what? The resistance is going to translate to 19.3 ohms. And then we are told that now we have diagram 2, so the two resistors are again rearranged, but we have gotten A is 19.3, and then you are told the second resistor is 13 ohms. So how is this going to affect the amount of current that is flowing? Now comment on the difference between the current in the battery. So we need to understand that the total resistance for the second circuit will be 19.3 plus 13 rather, 19.3 plus 13, which will be 32.3 ohms. Then we can be able to work out the current, because current is voltage divided by resistance, and that becomes 0.089. So you can see in diagram 2, we are going to have higher resistance, so less current will be able to flow in that circuit than diagram 1, where the components were arranged in parallel. When you have components arranged in parallel, you are going to have low resistance. So we need also to check the next part of the question. At this point, we're going to look at a student uses wax to attach one coin to the other. So you can see the steel is thinner, this is aluminum is thin, but this iron is thick, this one. So this experiment is not going to be a valid experiment because of the dimensions used are different, because you are timing how long it will take the coin to drop, so it's not going to be valid. And whenever you are asked dependent and independent variables, you need to understand that dependent variables are a variable is what you are measuring. Dependent variable is what you are measuring in the experiment, but the independent variable is what you change in the experiment, what you are changing in the experiment. So give the dependent variable in this investigation. Independent is the metal, because you are looking at different metals. That's what you are changing. But the dependent is the time. What you are measuring is the time in that case. So a teacher tells the student in the investigation is not valid. The fair test is the student should use rods of the same length and use coins of the same mass. Yeah, so it has to ensure that. But a reliability of the data or experiment depends on repeating experiment and calculating the mean. So that is also something that you need to understand. When you have discrete data, non-continuous data, the best way to investigate that data is by drawing a bar graph or a bar chart. So because data is not continuous, then non-continuous data are best investigated using bar charts. But if you have continuous data, you better use line graphs. So in your coming exams, we believe you can be able to answer a question like that. Which of these is the main source of energy in stars? That is nuclear fusion. Nuclear fusion, where lighter nuclei fuse to form heavy nuclei. The table lists stages of development of stars that has very much larger than the sun. Stages of a star of large mass than the sun. Remember, it starts from a protostar. Then the star moves to the main sequence. When all the main sequence, or the stable star, when all the hydrogen is used up, it collapses against gravity, and then it becomes a red supergiant. Then from the red supergiant, it becomes a supernova, which explodes to become a neutron star or a black hole. So those are the life stages of a star. If you got value from this particular video, consider subscribing and also sharing these tutorials and this video to your friends. Encourage them to join Proflan so that when we be doing more tutorials, you'll be notified. See you in the next video.